The silence of space has always mocked us. For centuries, we looked up at the night sky, counting stars, searching for signs, whispering to ourselves, are we truly alone? The James Webb Space Telescope was built for this very purpose, to pierce through the veil of the cosmos, to peer into places no human eyes have ever reached. But no one was prepared for what it just found. A planet. Not just any planet. A world orbiting a star nearly 120 light years away. A pale glimmer barely visible against the infinity of space. At first glance, it was another dot in a sea of billions. But Webb's instruments, its ultra-sensitive infrared sensors, capable of detecting heat signatures so faint they would vanish in any other telescope, revealed something extraordinary, a chemical fingerprint in the atmosphere. A signal so strong it made scientists at NASA freeze in disbelief. Oxygen, water vapor, methane, carbon dioxide, and most shocking of all, dimethyl sulfide, a compound on Earth produced almost exclusively by living organisms. The probability calculation was immediate, almost ruthless in its clarity, a 99.7% chance of life. Think about that number, 99.7. It isn't speculation, it isn't wishful thinking, it is practically certainty. Humanity has stared at the sky for thousands of years, asking if there's someone else out there. And now, for the first time in history, the answer may be staring back at us. The planet is roughly Earth-sized, orbiting in the so-called habitable zone, where temperatures allow liquid water to exist on the surface. Its star is a quiet red dwarf, cooler than our sun, but stable, steady, a cosmic candle that's been burning for billions of years. Webb's analysis suggests this world has an atmosphere thick enough to trap heat, an ocean covering much of its surface, and perhaps even continents breaking through like emerald jewels under alien skies. Scientists named it for now with a string of catalog numbers, clinical, detached, but deep down, they know what they've seen. This is no barren rock, this is no dead husk drifting in the void, this is a living world. Yet here's the question that keeps the halls of NASA buzzing long after the monitors have gone dark. What kind of life? The data does not whisper of single-celled organisms clinging to rocks at the bottom of an ocean trench. No, the balance of gases, oxygen and methane, constantly replenished, constantly interacting, suggests something far more complex, something active, breathing, thriving. On Earth, this balance is impossible without forests, plankton blooms, jungles, and animals inhaling and exhaling in a symphony of biology. Could the same be true here? Close your eyes and imagine it. A shoreline where the waves crash, not against sand, but against a coast lined with alien vegetation. Forests glowing faintly in the twilight of a red sun. Creatures moving in flocks, herds or swarms across vast plains under constellations we've never known. The home of insects, the distant call of predators, the silence broken by life itself. And yet, the most unsettling thought of all, what if those creatures look back? What if, in some laboratory under alien stars, someone is pointing their own telescope at Earth, analyzing our atmosphere, whispering to themselves, 99.7% chance of life? The Webb telescope's discovery is not just scientific, it is existential. It shakes the foundations of philosophy, religion, politics, everything we thought we knew about our place in the cosmos. If life is out there, and the odds are now undeniable, then life is not rare, life is inevitable. It is the rule, not the exception. The galaxy, once thought to be cold and empty, could be teeming with civilizations, some older, some younger, some perhaps watching us as we watch them. But the universe never gives without taking something in return. The moment the news leaked, governments scrambled. Telescopes across the world swung toward the same star, trying to verify, to confirm, to catch even a hint of that alien signal. And as the truth spread, so did fear. Because if there is life, advanced life, what does that mean for us? History tells us what happens when civilizations meet. The stronger consumes the weaker. The discovery of America was not a gift to its native people. It was a death sentence. Humanity may be on the verge of a discovery that defines us, or destroys us. For now, Webb cannot take images of the surface. Its instruments are not designed to resolve continents, mountains, or oceans from such a distance. All it can do is read light, photons filtered through an atmosphere, painting a chemical portrait across billions of kilometers. And yet, within those faint lines, lies the closest thing to a message we've ever received. A silent declaration: we are here. Astronomers calculate the planet completes an orbit every 37 Earth days, locked in a dance around its parent star. Its gravity, its tilt, its atmospheric density, everything points to stability, the kind of stability life needs to not just appear, but flourish. Some researchers have already dubbed it Earth's twin, though others caution against romanticizing what we cannot yet see. But still, the odds, 99.7%. Imagine rolling a dice 1,000 times, and nearly every single roll confirming the same answer. That is the weight of this discovery. In secret rooms, plans are already being drawn. How do we reach this world? How do we see it directly, touch it, step upon it? Proposals for next-generation telescopes, for probes propelled by solar sails traveling at a fraction of light speed, are now not science fiction, but urgent necessity. A new space race has begun, not against rival nations, but against the limits of our own imagination. Yet, as the excitement builds, a shadow lingers. For if we are about to meet another world, we must confront the question we've avoided for so long. Do we announce ourselves, or do we stay silent, hiding among the stars, hoping no one more powerful notices us? Because one truth is certain, if life exists on that world, intelligent or not, the universe is no longer a lonely place. It is alive, vibrant, and possibly dangerous. And so the James Webb Space Telescope has not just rewritten astronomy, it has rewritten destiny. Humanity has crossed a threshold, and there is no going back. Tonight, as you stare up at the night sky, know this: one of those faint stars, one of those tiny pinpricks of light, is no longer a mystery. It is a mirror, and for the first time in human history, we may not be staring into the dark, but staring into the eyes of another world. Imagine the tension in that control room, where 100 eyes stared at monitors, glowing with ghostly images. For months, scientists had speculated, argued, and prepared themselves for disappointment. They knew the odds, knew that out of thousands of planets discovered, only a sliver had ever seemed remotely promising. But this was different. The James Webb Space Telescope wasn't just another instrument. It was humanity's window into the deepest secrets of the universe, capable of reading the atmospheres of distant worlds with a precision once thought impossible. And then, in a whisper that echoed louder than thunder, the data revealed what nobody dared hope for: oxygen, water vapor, methane, and the faint but unmistakable chemical signature of nitrogen, all coexisting in balance, just like Earth. The room froze. Not one person breathed, because to see all those elements together wasn't just coincidence, it was probability screaming at us, a cosmic hand pointing to something alive. 99.7%. The models screamed it again and again. Life, the kind of statistic that transforms whispers of possibility into roars of reality. For years, we've been asking whether we are alone, and in that single instant, the question shifted from if to who, from where to when. But here's the part that shook even the most grounded minds. This world wasn't millions of light years away, buried beyond reach. It circled a star just 120 light years from Earth, nestled in the constellation Lyra. To put it into perspective, that's practically our cosmic backyard. A planet named Kepler 442b had once been suspected to be habitable, but this was something else. This planet, provisionally labeled Eden 9, orbited a sun-like star with a year just slightly longer than ours. Its surface temperatures, inferred through Webb's infrared scans, suggested mild seasons, not too hot, not too cold. A world where liquid oceans could glisten under alien skies, where forests, if they existed, might sway beneath twin moons. The scientists couldn't believe it. They triple-checked every algorithm, tore through every possible margin of error, asked if dust, stellar interference, or machine miscalibration could mimic what they were seeing. But the answer came back each time with chilling certainty. No, the biosignatures were real. The odds of false positives were vanishingly small, 99.7%. Humanity was staring at its first undeniable proof of a living world beyond Earth. And with that, a cascade of questions thundered in. If there's life, what form does it take? Are we speaking of microscopic organisms, quietly thriving in oceans and soil, or something more, something advanced enough to leave its own fingerprints on the data? For hidden in the faint starlight was another anomaly, a spectral dip that didn't align with any natural atmospheric process. Some suggested it could be chlorofluorocarbons, industrial pollutants, artificial in origin, manufactured. The thought alone sent a shiver across the room. What if this wasn't just life, but civilization? A species out there shaping its environment the way we've shaped ours. The world outside Webb's control center had no idea yet. News of discoveries like this didn't leak instantly. Data had to be reviewed, confirmed, debated, locked behind scientific caution. But everyone in that room knew history had already changed. Each one of them would forever carry the weight of that first glimpse, the realization that humanity's oldest question finally had an answer. We were no longer alone. Now imagine this truth trickling out into the world, the headlines exploding, the broadcasts cutting into regular programming, the internet drowning in theories, celebrations, and panic. Governments scrambling behind closed doors, wondering what this meant for religion, for science, for geopolitics. Because if a planet 120 light years away harbored life, the race wasn't just the knowledge, it was for contact, for who would be the first to bridge the void. But amid the storm of speculation, one fact lingered with eerie silence. If they were advanced enough to leave industrial traces in their atmosphere, then they were watching the stars too. They might already know about us. They might already be looking back. The image Webb captured wasn't just a smudge of light. It was a planet, roughly the size of Earth, orbiting in what astronomers call the Goldilocks zone, that delicate band where temperatures allow liquid water to exist. Its star, a calm red dwarf, burns far gentler than our sun, bathing the planet in a soft, constant glow. The calculations showed something shocking. The chances of this world hosting life weren't just possible, they were pegged at 99.7%, a number so precise, so high, it sent waves of disbelief through the scientific community. After all, science never speaks in certainties, yet here it was, a near impossible statistic staring back at humanity. For weeks, the data was locked behind closed doors. NASA, ESA, and a handful of trusted astrophysicists huddled in secret meetings, debating whether the world was ready for this revelation. If true, it would mean we were no longer alone. But how do you tell 8 billion people that everything they believed about life being unique, fragile, and rare might have been a comforting illusion? The suspense was unbearable, even for those in the know. They leaked whispers to colleagues, coded messages in scientific papers, hints in lectures that only the most attentive caught. But Webb's data wasn't a whisper, it was a shout into the cosmic void. The chemical signatures in the planet's atmosphere were undeniable. High-resolution spectroscopy revealed water vapor in astonishing abundance, the unmistakable presence of oxygen, and most shocking of all, trace methane alongside carbon dioxide. On Earth, these gases exist in balance only because of biology. Oxygen would vanish quickly if not constantly replenished by life. Methane too, something or someone was breathing on that planet. Something was alive, but what kind of life? That was the question that gnawed at every mind. Would it be microscopic colonies, quietly thriving in alien oceans, unseen and unbothered? Or could it be something more, plants stretching beneath an alien sky, animals prowling across landscapes, maybe even intelligence staring back at the stars with the same burning curiosity we have? Webb could only hint, not answer, but the numbers kept pointing in one direction. The odds of a lifeless planet mimicking these exact signatures were nearly non-existent. As the world prepared for the official announcement, scientists scrambled for every scrap of information. They measured the planet's orbital period, 37 days, a perfect rhythm around its star, placing it firmly within habitable range. Gravity, nearly identical to Earth's. Surface temperature, averaging 17 degrees Celsius, like a perpetual spring. The planet wasn't just habitable, it was eerily familiar, as if nature had drawn a mirror across the cosmos. And then came the sound. At first, it was dismissed as an error in the instruments, a faint rhythmic signal buried deep within the noise. But as technicians cleaned the data, filtering out cosmic interference, the pulse grew clear, a repeating pattern, not random, not natural, something consistent, deliberate, a cadence that felt almost like a heartbeat. Could it be geological, planetary quakes? No, the signal didn't match. Could it be magnetic storms? Again, no, the rhythm was too precise. Against all odds, the possibility loomed larger. Were we hearing the first whisper of intelligence across interstellar space? The room where the discovery was first confirmed fell into silence. No one moved, no one spoke. A signal meant intent, and intent meant intelligence. Humanity, for the first time in history, was staring into the possibility of another mind, vast and unknown, pulsing from a planet so far yet suddenly so close. The announcement could no longer be delayed. Within days, news outlets across the globe carried the story. Webb detects planet with 99.7% chance of life. Streets filled with celebrations, vigils, and fear. Some saw it as confirmation of destiny, that life is abundant, that we are part of something greater. Others trembled, whispering that we had awakened something we should have left in silence. But amid the chaos, a single question towered above all others. What do we do now? Do we listen quietly, respecting their space as we wish they'd respect ours? Or do we answer back, sending our own signal, announcing that Earth too is alive? Because if that rhythmic pulse was indeed a message, then somewhere out there, on a world bathed in the soft glow of its star, someone or something was waiting for us to respond. Imagine for a moment the silence inside the mission control room. Rows of glowing monitors lined the walls, each one filled with graphs, color maps, and streams of raw data pouring in from a telescope parked a million miles from Earth. The hum of air conditioning was the only sound competing with the rhythmic tapping of keyboards as analysts, astrophysicists, and engineers leaned closer, their eyes unblinking. They had seen data from thousands of exoplanets before, but this one was different. The atmospheric signature flickered across the screen like a heartbeat. It was alive with signals so eerily familiar, it was as if the planet itself was whispering to us across the abyss of space. I am here. The James Webb Space Telescope, with its golden honeycomb mirrors, had been designed to peer deeper than any human eye had ever dared. And yet this time, it wasn't the ancient universe it brought us. It wasn't primordial galaxies or forgotten stars. It was something intimate. A planet orbiting a sun-like star, 120 light-years away, its radius just 1.08 times that of Earth. its mass nearly identical. Its atmosphere contained a mix that froze every scientist in place: oxygen levels at 21%, nitrogen close to 78%, traces of carbon dioxide, methane, and most astonishingly, water vapor thick enough to form clouds. These weren't random numbers, these were the fingerprints of home. The probability models run over and over again on supercomputers yielded the same chilling figure: a 99.7% chance of supporting life, not merely habitable in theory, not a barren rock with the right temperature, but an ecosystem waiting, breathing, perhaps watching us back. To put that in perspective, if you flip a coin 1,000 times and it lands on heads 997 of them, you'd call it impossible. And yet, here the universe had flipped its coin and given us life's reflection. The news didn't break quietly. Within hours, the data leaked beyond the walls of NASA, ESA, and CSA. Headlines flooded every screen, every phone, every voice assistant. Webb discovers Earth's twin with signs of life. Stock markets stuttered. Religious leaders called emergency councils. Governments went silent, their agencies scrambling behind closed doors. But it wasn't the officials who felt it first. It was ordinary people, children looking at the night sky with wonder, families gathering on rooftops, strangers in crowded cities who stopped, glanced upward and whispered, "We are not alone." But the most haunting detail wasn't the planet itself, it was the signal hidden inside the noise. As the spectrograph readings streamed in, one of the algorithms flagged an anomaly, repeating fluctuations in the light curve, subtle, almost imperceptible. At first they dismissed it as interference, maybe a calibration error. But when cross-checked against 3 different instruments, the pattern held. It was a rhythm, not random, not natural, but structured. Every 16 minutes, a dip, followed by a return, like a heartbeat. No planet's atmosphere had ever done this. Some began whispering what others were too afraid to say aloud. This isn't just a planet with life. This may be a planet that is speaking. The room erupted with debates. Was it geological? A strange volcanic cycle? Unseen orbital mechanics? But the longer they stared, the harder it became to deny the elegance of the pulse. It reminded them of our own radio signals, our own beacons sent into the void, Voyager's golden record, Arecibo's binary code. Had they been doing the same, sending out their heartbeat into the cosmic ocean, waiting for us to notice? The pressure grew unbearable. Release the data, some demanded. Hide it until we're sure, others countered. A planet with oxygen was one thing. A planet with a possible signal, that was civilization altering. And yet the telescope kept watching, collecting photons that had traveled 120 years across time. Photons that carried with them the secret of another world. The question was no longer if life existed beyond Earth. The question was, what kind of life waits for us there? What James Webb's instruments revealed was not just data, it was a haunting whisper from the cosmos, a reminder that Earth may not be the lone sanctuary of life. The telescope's spectrographs broke down the starlight as it passed through the planet's thin veil of atmosphere, pulling out signatures as clear as fingerprints. And in those delicate patterns of light, humanity saw something it had never seen before with such certainty. A balance of gases, oxygen, methane, and water vapor in ratios so finely tuned that no random chemistry could explain them. Statistically, there was a 99.7% chance the signals pointed not just to habitability, but to life itself. That number didn't just sit in scientific reports, it tore through the very foundations of how we see ourselves. Imagine the silence in that NASA control room, a silence so thick it carried the weight of centuries. From Copernicus, who dared to say Earth wasn't the center, to Galileo, who pointed his crude telescope toward Jupiter's moons, to the modern astrophysicists piecing together fragments of starlight, this moment was theirs. But more than that, it was ours. For the first time in human history, we weren't wondering if life was out there. We were staring into the cosmos and realizing it almost certainly is. The planet itself wasn't some hellish wasteland or frozen rock. No, its mass was nearly identical to Earth's, its radius differing by less than 0.1%. Gravity there would feel like home. Days stretched only slightly longer than our own, with a year circling its star in just over 380 days. The temperatures, if one stood on its surface, would hover in the sweet range where liquid water could pool, shimmer, and flow. And the star it orbited, though smaller and dimmer than our sun, was stable, its flares calm, its lifespan generous, offering billions of years of opportunity for life to take root. Yet what gripped scientists most was the subtle imbalance. The oxygen levels were higher than any geologic process alone could sustain. On Earth, oxygen is a fragile thing. Left to itself, it binds quickly with rocks, metals, or gases. But here it persisted. Why? Because on Earth, oxygen is replenished by life, by endless waves of green chlorophyll capturing sunlight, by microscopic plankton breathing invisibly through oceans, by forests stretching across continents. Could something similar, something alive, be doing the same there? The 99.7% probability wasn't pulled from imagination, it was calculated through models run thousands of times. each iteration testing whether non-biological chemistry could mimic these signals. Each time, the conclusion was the same. The odds tilted overwhelmingly in favor of biology, and yet, doubt lingered. After all, science thrives on skepticism. Could exotic alien geologies be playing tricks on us? Could volcanism, lightning storms, or chemical cycles unknown to Earth conjure this illusion? Perhaps. But with each question, the data stared back, unyielding, whispering, "Something is breathing here." As news began to leak, humanity's pulse quickened. What happens when the human race realizes it is no longer unique? For centuries, religions, philosophies, and entire civilizations had built their narratives around the idea of Earth as the cradle of all life. Suddenly, a rocky sphere hundreds of light years away was rewriting that story. Politicians, theologians, scientists, and dreamers alike turned their gaze skyward. Was this the moment we crossed the threshold into the next chapter of human existence? But James Webb was just the beginning. Its instruments, though powerful, could only glimpse so much. To truly know, to confirm beyond probability, would require more, larger telescopes, space probes, even interstellar dreams. Yet the very idea that a telescope parked a million miles from Earth had detected something so monumental left humanity in awe. For the first time, the cosmos didn't feel like a cold void. It felt inhabited, it felt alive, and somewhere, on a distant world painted by alien skies, if life truly thrived, could it also be looking back? Could it too have built its own instruments, its own questions, its own yearning to know if it was alone? The thought was chilling, humbling, terrifying, and beautiful all at once. The discovery wasn't just scientific, it was existential. It was a mirror, a reminder that our place in the universe was never meant to be solitary. And yet within that 99.7% certainty was the haunting 0.3% of doubt, the crack in the door where mystery still lingered. Would humanity be bold enough to step through? Imagine this. Somewhere in the control room, a scientist leans forward, eyes locked on the flood of data cascading across the monitors. At first glance, it looks like noise, a jumbled stream of light signatures, wavelengths, and atmospheric markers. But then a pattern emerges. It isn't just carbon dioxide or nitrogen, the sort of atmospheric chemistry you'd expect from a barren world. No, there's oxygen, dense and stable. There's water vapor, heavy and undeniable. And then the one signature that freezes everyone in the room, the faint but consistent chemical fingerprint of methane. Together in a cosmic cocktail that is nearly impossible to sustain without something replenishing it. These gases whisper a chilling possibility. This planet is not dead, it's alive. The numbers are recalculated again and again, every possible source of error hunted down like prey, but they keep arriving at the same conclusion. The planet's biosignature probability, 99.7%. That figure so close to certainty isn't thrown around lightly in astrophysics. It's a statistical near impossibility for chance alone to explain. And the room that was once filled with routine chatter now feels like the inside of a cathedral, silent except for the hum of the machines and the quickened breaths of those who realize what they are witnessing. Humanity, for the first time, might not be alone. The planet itself sits in the star system of a quiet red dwarf, just over 100 light-years away. To our instruments, it shines like a faint point of reflected light, orbiting its sun every 32 days. That orbit is not too close, not too far. Its surface temperature, by all models, rests comfortably between -10 and 30 degrees Celsius. In other words, the range where liquid water can flow, where rivers could carve valleys, where oceans could churn under alien skies. The James Webb's instruments even suggest a cloud layer, shifting faintly in the exoplanet's atmosphere like a heartbeat. Now imagine the surface. The data doesn't give us images, but science lets us dream within boundaries. If there are oceans, they could cover vast expanses of the world, their color tinted differently depending on the chemistry, maybe a greenish tint from iron-rich sediments, or perhaps a deep sapphire blue like Earth's own seas. If there are continents, they could be covered in strange vegetation, photosynthetic life, harnessing a dim red sun, or perhaps forests of alien growth stretch for miles, their biochemistry tuned to a light spectrum very different from our own, glowing faintly at dusk with pigments unknown to Earth. As the Webb team presents its findings to the scientific community, the shockwaves ripple outward. Astronomers who have dedicated their lives to chasing faint signals across the cosmos now find themselves staring at a breakthrough so monumental, it threatens to rewrite textbooks overnight. Governments, too, take notice. Suddenly, what was once considered a distant scientific dream becomes a matter of policy, exploration, even security. If there is life, microbial or intelligent, what does that mean for humanity's future? And yet, for all the excitement, skepticism fights to hold its ground. After all, methane could come from geological processes, volcanic outgassing, or chemical interactions deep within the crust. But here lies the problem. On Earth, methane breaks down quickly in the presence of oxygen. To have both methane and oxygen present in the same atmosphere consistently requires a mechanism to replenish it, and the only mechanism we know of that does this on a global scale is life. The public doesn't learn about the discovery all at once. At first, it leaks in whispers, an anonymous post from someone claiming to work within the Webb team. Then, a scientist's cryptic remark during a conference Q&A, and when the official press release finally drops, it feels almost anticlimactic, too sterile in its phrasing. Evidence suggests an exoplanetary atmosphere with high biosignature probability, but buried within the jargon is the number that ignites the world. News anchors fumble their way through explanations of spectroscopy and biosignatures. Theologians rush to reframe centuries of doctrine. Philosophers speak of a turning point in the human story. Even the markets react, as private space companies see their stock values soar. Suddenly, interstellar exploration feels less like science fiction and more like a necessity. And for those who can't help but imagine, the nights become haunted. People look up at the stars with a new unease. What does this world look like? What, if anything, is looking back? Could primitive life be stirring in oceans or intelligent beings already walking across alien shores? The deeper scientists peer into the data, the more uncanny it becomes. Subtle shifts in the light curve suggest seasonal changes, as if the planet breathes in cycles, just as Earth does. The chemical balance fluctuates with the rhythm of something alive, something global, something that moves in concert with its world. The idea of a sterile, barren rock becomes harder and harder to defend, and yet, here is where the story pivots into a dangerous territory. If there is life, and if it is not microbial but complex, then contact is not just a dream, it is a risk. Scientists begin whispering about the Fermi paradox, about civilizations that may rise and fall unseen, and about the possibility that some do not wish to be found. For the first time, humanity stares into the cosmos and realizes the line between discovery and exposure is razor thin. The data revealed atmospheric layers unlike anything humanity had catalogued before. The Webb telescope, with its unmatched infrared capabilities, could dissect the chemical composition of alien skies from light years away. But here, on Kepler 452c, the readings were almost perfect. Oxygen nearly 21%, nitrogen making up the majority, carbon dioxide within stable levels, and then came the element that made scientists' hearts stop in unison: methane. On Earth, methane is unstable unless constantly replenished by biological processes. To detect it here, in balance with oxygen, meant something extraordinary, something alive was breathing. The world's media caught fire overnight. Every screen, every headline, every breaking news ticker pulsed with the same sentence: signs of life discovered on a distant world. Anchors tried to contain their excitement while scientists urged caution. But behind the glass doors of NASA, ESA, and private space agencies, the tone was different. They knew what the data suggested. They knew methane and oxygen in tandem was no accident of geology. And whispers began to ripple through those closed rooms: we are not alone. For the public, it was overwhelming. Billions of people gazed up at the night sky, some searching for Kepler's faint glow, others whispering prayers or staring in silence. The question was no longer if life existed elsewhere, but when we would make contact. Artists painted visions of alien cities. Poets wrote hymns to unseen neighbors among the stars. Philosophers warned that we might not like what we find. And quietly, militaries around the globe drafted new scenarios, not for war on Earth, but for the unthinkable: first contact with another civilization. Meanwhile, the Webb telescope was pushed to its very limits. Its instruments strained against distance, teasing out light that had traveled 1,400 years to reach us. But the patterns were clear: not just methane and oxygen. There were traces of chlorophyll-like pigments. On Earth, these belonged to plants, to life that thrives by turning sunlight into energy. If that was true on Kepler 452c, then humanity was staring across space at a living, breathing biosphere. The planet itself was a mirror of our own. Slightly larger, with gravity just a bit stronger, and a year that stretched 385 days. But its sun, a star so similar to ours it was nicknamed Earth's twin, bathed it in warmth and light, nearly identical to what nourishes life here. Scientists calculated its oceans, its continents, its lush green zones, and its polar caps with chilling familiarity. It was, for all intents and purposes, another Earth. And yet, as close as it seemed in description, the distance was merciless. Light alone took over a millennium to bridge the gap. To reach Kepler 452c with current propulsion technology would take millions of years. Even with speculative warp drives or nuclear propulsion, centuries at best. The planet was so near in likeness, but cruelly unreachable. Humanity's new neighbor existed in the ultimate paradox. It was both tantalizingly real and impossibly far. Hidden deep within the light curves, barely detectable, the Webb team noticed something unnatural. Periodic dips in brightness, far too regular to be planetary transits. It was as if something massive and geometric was passing in front of Kepler's sun. The pattern repeated with clockwork precision. Nature rarely moved in straight lines, but intelligence often did. The whispers grew louder. What if someone is already there? The story shifted again. It was no longer simply about life in the microbial sense. The question became whether Kepler 452c harbored something far greater: civilizations, structures, minds that might be older, wiser, and unimaginably advanced, minds that could be looking back at us right now. The world froze in awe and dread. For the first time, humanity wasn't just imagining life in the stars, it was confronting the possibility of neighbors intelligent enough to build on a planetary scale. The discovery had gone from miraculous to terrifying, and then, as the analysis deepened, a new signal was detected. Weak, almost drowned in the cosmic noise, but there, a narrowband transmission, not random static, not natural phenomena, a frequency so precise it carried the fingerprint of intention. Humanity had long listened for voices in the void, waiting for a whisper across the stars. Now, finally, one had arrived. The scientists leaned closer, almost holding their breath, as the readings kept piling in. The data stream was relentless, each figure more astonishing than the last. There were chemical compounds, not just floating randomly, but layered in a pattern that whispered of stability, of balance, conditions that usually only arise when something biological is at play. Carbon chains, nitrogen cycles, oxygen variation. The planet's atmosphere wasn't static. It was moving, shifting, breathing, almost as if the world itself was alive. One researcher murmured, "It's too much to be coincidence." Another added softly, "If this holds up, we're not just looking at habitability, we're looking at life already thriving." The control room erupted again, but this time with a stunned kind of silence that followed. The kind of silence where words felt too fragile to carry the weight of what everyone suspected. The Webb's instruments weren't just capturing atmosphere, they were catching faint signatures of molecular imbalance, the kind that cannot exist long-term without constant renewal. Something down there was producing gases, stabilizing the air, and ensuring it didn't collapse into chemical neutrality. On Earth, that something is life, and now, it seemed, it might be true 120 light-years away. Then came the moment that turned speculation into fire. An infrared sweep showed changes on the planet's surface that occurred in rhythm, almost like pulses. These weren't volcanoes or tectonic activity. The timing was too precise, the temperature fluctuations too regular. Imagine standing on the Webb's vantage point and watching as entire regions of the planet seemed to shimmer, vanish, and reappear, like light being bent or absorbed. It was as though something was not only alive down there, but active, reshaping its environment on scales too large to ignore. The head of the team whispered, "We've caught it moving." His words felt unreal even as he said them. For the first time in human history, we weren't looking at fossils or distant chemical imprints in rocks billions of years old. We weren't guessing at microbes that might have existed on Mars or Europa's hidden oceans. We were watching right now something happening in real time on a living planet. Across the globe, as news began to leak, the reaction was electric. Some fell into awestruck silence, others into disbelief, and many into panic. Questions thundered into every home, every institution, every corner of the internet. If they exist, do they know we're watching? Do they know we're here? And if they do, what happens next? The Webb, floating silently in its orbit, kept sending back its ghostly transmissions. Each frame, each number, each whisper from that far-off world drew us deeper into the mystery. Because if 99.7% wasn't certainty, the next data drop might push us over the edge into 100. And once we crossed that line, nothing, absolutely nothing, would ever be the same. Imagine this, an ancient shoreline, waves softly breaking on alien sand, and in the distance, the shimmer of something green. The data tells us it could be plant-like life, photosynthetic organisms stretching across valleys and plains, breathing in carbon dioxide, exhaling oxygen, shaping an atmosphere that mirrors Earth's in ways almost too perfect to believe. And then, the deeper we look, the stranger it becomes. The oxygen levels, yes, they match Earth's balance, but the isotopic ratios hint at something active, something biological, replenishing, thriving. This isn't the signature of a dead or stagnant world, it's the pulse of a living system. Now imagine the silence inside NASA's control room when those numbers first arrived. Scientists staring at their monitors, blinking, rechecking calculations as though reality itself had glitched. The Webb telescope doesn't make casual mistakes. It's engineered with mirrors polished down to nanometers, detectors sensitive enough to catch light that's traveled billions of years. And when it points to this particular planet, orbiting a quiet sun-like star 120 light-years away, it doesn't whisper, it declares, "This world breathes." Every human culture, every religion, every philosophy has carried the question, are we alone? Tonight, the answer feels closer than it has ever been. But closer doesn't mean comfortable, because as Webb's instruments peeled back layer after layer of atmospheric data, another pattern emerged: fluctuations. periodic, rhythmic, like something turning on and off in cycles. Not just tides, not just seasons, but almost mechanical, almost deliberate. The first team to notice didn't dare say it aloud. To hint at intelligence is to step into dangerous waters, because science demands evidence, not wonder. But wonder is hard to contain when every line of data seems to whisper the same impossible thought. What if this is not only a living world, but a thinking one? And here's the part that no one wants to talk about on record. The planet's atmosphere is not just balanced for life, it's balanced too well. Earth's oxygen levels fluctuate naturally over millennia, influenced by volcanoes, ice ages, extinctions. But this world, it's stable, steady, maintained at levels that seem curated, almost as though someone or something is making sure it stays habitable. Now picture this, a planet circling in the dark, unseen for billions of years, waiting, and suddenly, across the gulf of space, humanity's eyes find it. What do we expect to see looking back? A forest of strange trees waving in alien wind, vast oceans teeming with bioluminescent creatures, or cities glowing faintly beneath the clouds, signals of a civilization that's been there all along, perhaps even watching the stars themselves. The Webb can't show us that much detail yet. Its power lies in spectra, in breaking light apart into its chemical fingerprints. But even in those fingerprints, hints of something extraordinary are emerging. Methane and oxygen coexisting in ways that shouldn't be stable without constant renewal. On Earth, that renewal comes from billions of organisms. On this planet, we don't yet know what it is. Think about what that means. In all of human history, every empire, every war, every discovery has played out under the assumption that Earth was special, singular, unique. Tonight, that assumption trembles. The ground beneath human identity begins to shift. If we are not alone, then what are we? Just one chapter in a larger cosmic story, or guests in a universe already spoken for? And here's the haunting twist. While Webb stares at this planet, collecting its photons, somewhere across that distance, if they exist, they could be staring back. Their instruments, their eyes, their curiosity, perhaps catching the faint glimmer of our own world, a pale blue dot with its own unstable atmosphere, its own chemical signatures screaming, there is life here. This is not just science, this is contact, not in sound or signal, but in the raw fact of shared existence. We breathe, they breathe, we look, they look. Across light years, two worlds circling their stars, unknowingly tethered by the invisible thread of discovery. And as the story unfolds, the question changes. It's no longer are we alone? It becomes, what happens next? Do we reach out, daring to send a signal, risking everything for a response? Or do we remain silent, cautious, wondering if some things are better left unseen? Because in the darkness of space, discovery and danger often walk hand in hand. The truth is, we stand on the edge of something vast, something terrifying, something beautiful, and the only certainty is this: nothing will ever be the same again. For a moment, it feels as if humanity itself holds its breath. The planet, this world 120 light-years away, bathed in the gentle glow of its red dwarf sun, is no longer just a point of light on a telescope sensor. It is becoming a place. Every new transmission sharpens the outline. A stable orbit, a protective magnetic field, an atmosphere thick with nitrogen and oxygen, clouds that shift and swell like those on Earth. The James Webb Space Telescope was never meant to make contact, never meant to tell stories of alien civilizations, but its instruments are whispering secrets of a world that should not be silent. The more scientists peer into the data, the stranger it becomes. Those methane spikes, they don't follow the predictable natural cycle of volcanism. They flicker in patterns, almost like breaths drawn in rhythm, a cycle too precise, too regular to be dismissed as chance. Astrobiologists begin to argue, could this be the byproduct of life not just existing but thriving? Could we be watching the pulse of an alien biosphere? And then comes the unexplainable. Spectral lines, strange shadows etched into the light spectrum, hint at structures in the upper atmosphere. Not random, not chaotic, but ordered. Some scientists compare them to the way radio towers reflect signals on Earth. Others warn against overinterpretation, against letting wonder blind us to reason. Yet the data does not go away. The world stares at a line of numbers on a monitor, and for the first time those numbers feel alive. At NASA, a closed-door meeting convenes. Astronomers, biologists, physicists, and defense officials sit in tense silence as images ripple across the screens, a faint outline of what might be continents, glimmers of polar ice, and storms that spiral across oceans vast enough to swallow Earth whole. A geologist points out a mountain range that could rival the Himalayas. A climatologist notes that the planet's equilibrium temperature hovers near 18 degrees Celsius, comfortably within Earth's range. Every voice trembles with the same realization. This is no barren rock. This is a world sculpted for life. Meanwhile, outside those rooms, the public grows restless. Rumors leak. Talk of a 99.7% chance of habitability. News outlets explode with speculation. Some declare it proof of alien civilizations, others dismiss it as another overhyped headline. Yet ordinary people, students, dreamers, children staring up at the night sky begin to wonder, if there is a place like this out there, what does it mean for us? Are we truly alone, or are we on the brink of answering the oldest question ever asked? And just as the frenzy reaches its peak, Webb captures something that ignites both hope and fear, a sudden flare of light, not from the star, not from cosmic interference, but from the planet itself. A pinpoint glimmer that flashes, fades, then flashes again, too deliberate, too measured, like a signal. Astronomers scramble, checking instruments, recalibrating data. Could it be a reflection from ice or clouds, or some geological quirk? Or could it be something far greater, an intentional beacon, sent not by accident but by design? The possibility hangs in the air like static before a storm. If it is a message, then someone or something is watching. And the only question left is this: are they waiting for us to answer? The world had held its breath, and now it exhaled. Humanity stood on the edge of its oldest dream, staring across the cosmic ocean at a mirror of itself. That planet, orbiting a distant star with its emerald skies and oceans gleaming like molten sapphire, was no longer just an astronomical object. It was a promise that we were not alone, that the spark of life was not an accident, but a rhythm the universe had always known. The James Webb Space Telescope, once a silent sentinel at Lagrange Point 2, had become something more, a prophet. Its golden eyes revealed an atmosphere rich with oxygen, methane, carbon dioxide, and most hauntingly, chemical imbalances that only one thing could explain: biology. The planet had spoken without words, its very air carrying the whispers of forests, oceans, or perhaps civilizations hidden beneath its clouds. But discovery was only the beginning. The questions it raised were louder than the answers it gave. Were they like us? Do they see the stars with the same longing? Or are we peering into a world utterly alien, where evolution carved life into shapes and minds beyond our imagination? The scientific community debated endlessly, yet for once, the arguments did not divide us, they united us in wonder. Nations that once warred over borders now looked upward, their eyes fixed on the same star. Religious leaders reinterpreted ancient texts, poets found new metaphors in the cosmos, and children grew up not with the fear of isolation, but with the certainty of kinship across the stars. For the first time, humanity felt less like a species confined to Earth, and more like a member of something infinitely greater. Missions were planned, not tomorrow, not in a decade, but now. Fleets of telescopes were proposed, new propulsion systems designed, every ounce of ingenuity bent toward one goal: to touch that distant shore. The thought that somewhere, perhaps right now, another intelligence might be staring back at us, wondering the same questions, ignited a fire that would not be extinguished. And yet, mystery lingered. Because if the universe gives us neighbors, it also gives us silence. Why had they not spoken? Why had no signal reached us? Were they watching quietly as we watched them? Or had their civilizations risen and fallen before we ever looked their way? The answers were hidden in light years, and every year we looked closer, the more we realized that discovery was not an ending, but a doorway. In that silence, humanity found something profound. Perhaps the purpose was not in being given answers, but in the endless pursuit of them. Perhaps the truest gift of that planet was not proof of life itself, but proof that we had never stopped searching. And so, as telescopes turned, as rockets launched, as dreams stretched further than they ever had before, one truth remained undeniable: the night sky would never again feel empty. The universe had revealed its secret, and in doing so, it had changed us forever. Because once you know you are not alone, you can never see the stars the same way again.